In this video, we will get an understanding of how variables are used in coding. You can think of a variable as a container in memory that stores some data. Each variable has a unique name of your own choice. The variable name points to the specific address in memory where the data is stored. In the example, two variables are defined, called var1 and var2. When coding, you can use the variable name to get or set the value of the variable. In this example, we are setting the value of var1 and var2. You can also use the variable name to retrieve the value of the variable from memory. In the example, the values of variable 2 will be retrieved from memory, and then assigned to variable 3. Variables can contain different data types. In the example, we now create a fourth variable, and assign its value to be a string of text. When naming variables, you should try to choose names that are short but descriptive. In the example, the variables have now been renamed to make them more understandable. Let's have a look at the naming rules for variables. In Mobius Modeller, there are 3 variable naming rules. The first 2 rules will apply in most other programming languages, but other languages may have additional rules. We will go through the 3 Mobius Modeller rules, each one in turn. Rule 1. Variable names can only contain letters, numbers, and underscores. You cannot use spaces or hyphens. If your variable name consists of multiple words, it is advisable to separate them using underscores. This can make the code more readable. Rule 2. You can start your variable with a number. It must start with either a letter or an underscore. Rule 3. The letters in the variable name must all be lowercase. This last rule is not common in other programming languages. However, we have found that novice programmers will often make mistakes, mixing up lower and uppercase letters. So we have added this rule. If you do try to name a variable with uppercase letters, Mobius will automatically convert them to lowercase. Now let's go through some examples. In this example, variable x equals 1 and variable y equals 10. Let's create another variable called total, and give it a value of x plus y. The final value of total will be 11. In this example, we do a similar calculation. But before adding the 2 numbers, we have changed the value of x from 1 to 100. The previous value of 1 is overwritten by the new value. Adding the 2 numbers now gives a total of 110. In this example, we also changed the value of x from 1 to 100. However, we do it after having added the 2 numbers. When the total is calculated, the value of x is still 1. So the total is still 11. Changing x after having calculated the total will have no impact on x. In this example, we assign one variable to another variable. When line 2 is executed, the value of x is retrieved from memory and assigned to the variable y. Both variables will therefore have a value of 1. And the total will be 2. In this final example, in line 1, we first assign a value of 1 to the variable x. In line 2, we assign the value of x to the variable y. So x and y now both have a value of 1. In line 3, we assign a new value to x. But this has no impact on y. So after executing line 3, x will have a value of 100 and y will have a value of 1. So the total will be 101.